if you want to say oxygen can carry +2 charge, it never going to happen. It is always incorrect. As I told you, it is in group 6A. It means if it's going to form ion, either it's going to stay as an element, or if it's going to form ion, it's always going to be -2.
Is that the same for 5A then? It could never do the plus charge. It would always be -3 and then -2.
For which one?
For 5A, is that the same? It
Oh,
would.
yes, always -3. If you're talking about ion, then yes, always 3. If
Okay.
it's forming a molecular compound, it is a different story, right? But not ion, no charge. Yeah. All right, so let me just show you why oxygen is going to be -2. So just to make sure that you guys kind of get the idea, right? So again, for this, I'm gonna ask you oxygen, right? What is atomic number?
Eight.
Everybody, did you find it out?
8.
Yeah, 8.
8.
Of course, right? It is 8. It means what should be the number of proton?
8.
Everybody agree? What should be the number of electron?
8.
8, because this is an element. I did not write any charge, right? Now, let's just draw the atomic diagram, right? The diagram that we drew earlier, this is called atomic diagram, right? Because this is atom of oxygen. So this is nucleus. The first shell, it's going to have 2 electrons. So now I'm going to change the color. 2 electron. So 2 here. The second shell can have 8 electrons, right? So instead of drawing all of them, I'm just going to, yeah, I think I should draw them, right? So how many more electron are we going to put in this shell? This is the first shell.
6.
Into the second cell. So yes, because we have only 8 electrons, we already put 2 electron here. So at the moment we just have 6 more. So 1, 2, 3, 4, 5, and 6. So this is how the electron looks like, or we can see this is how the atomic structure look like for oxygen. Now, as we know the octet rule, right? Everybody like to have, like I would say, every element will like to have 8 electron. So in this case, what are the two options? The first option is to gain 2 electrons, and the second option is to lose how many? 6 electrons. What do you think is easy option for oxygen?
2 electrons.
Or no deal? Deal or no deal? Of course, deal with gaining 2 more electrons, right? Easy for oxygen to do. So let's say this is the second oxygen. These are the 2 oxygen these are the 2 electron oxygen is getting. What does it mean? Now its octet is complete. To complete the octet, what does oxygen has to end up with? It has to gain 2 electron. If it's gaining 2 electron, of course, because it's electron, it's gonna negative charge, and gain 2 electron, it should be -2. Do you follow this?
Yeah.
Everyone?
Yes.
Yes, so that's why it's going to be -2. As I told you, it is always going to be -2 if it's forming ion, right? You can apply the same concept to any element. Basically the group that I told you, 1, 2, 3A, and 7, 6, and 5A, right? And it does follow this rule. All right. If it's non-metal, if it's metalloid, it is of course confusing, but you don't need to know that at the moment. All right, not even for the entire course you are taking, so don't worry about that. All right, so is that clear to you guys, everybody? Any other question from this?
No. No questions.
No questions.
No question. So again, I'm just gonna point this out one more time just to make sure that you guys know this answer. So let's say if I'm gonna give you O-2 symbol, and if I'm gonna ask you what is the number of proton, remember it is same as an element, so 8. What is number of neutron? Again, we don't have to find out right now, but it is again going to be the same as element, right? But the number of electron, what do you think it is?
10.
Excellent, right? You already know as an oxygen, right? It should have 8, and now -2 means 2 more electrons. So for electron, you're going to say +2. Why? Because we are adding 2 more electron. So it becomes 10. So this should be the answer.
So where does it get the 2 electrons?
That is a really good question. And we are going to talk about that when we talk about ionic compound, right? So do you know the symbol NaCl? What is that? Do you know?
Salt.
Sodium chlorine?
Yeah.
Yeah, so basically it's salt. You know, the salt that we eat, like table salt, that's the symbol for salt is NaCl. What is NaCl? It is a compound. So when it form ion, it does not exist by itself. It exists with some other elements, right? So there must be other element present which can donate these 2 electron. And if somebody is donating electron, then there must be another element present to accept those 2 electron. Otherwise, this gaining and losing electron never happens, right? For
That makes sense.
right, for exchange, there must be 2 people, right? If you want to exchange vows, or if you want to marry, there must be another person, right? Same way for element, if they want to exchange, they must need another element. Yeah.
Yeah. So you get
Got it.
2 electron from chloride.
Yeah. So
Okay.
yeah, so in Na, basically, like I think we talked about it, so I can tell you this, right? Na become +1, Cl become -1. What does it mean? One of the electron from sodium that we saw earlier, right? Sodium will like to lose 1 electron, right? So one of the electron that sodium is going to lose will be accepted by chlorine. All right, so it will be both happy. If you want to remind me one more time, let's say I'm just not going to write all the numbers, but I can just write down electron arrangement. So this is the basically atomic diagram of sodium. In the first orbital, there should be 2, as we know. Second orbital maximum is 8, and the third orbital, because we just have 1 more electron, right? Sodium is 11, so we can have 1. For chlorine, let's say, yeah, for chlorine, let me just tell you that. So 2, 8, and 7.
Chlorine is 17.
Yeah, so it should be like this, right? 2, 8, and 7. This is for chlorine. All right, so what is going to happen, right? Let me just change the color so you know what I'm talking about. So sodium is going to lose this electron, right? That's why it's going to become +1, and this electron is going to go and be placed in this Cl. So that's why it's going to become -1. Do you see what I did?
Yes.
Yeah.
Right.
Uh,
Yeah, go ahead.
So you lose 1 electron, then you just put you put like plus sign on sodium, like on place of the exponent.
It should be at the that's called superscript, right? If you write something on the right top corner, if you write something on the right top corner of any symbol, that is called superscript.
Okay, at the superscript, anytime you lose like any amount, like just like even if you lose 1 electron, you always write write it like a plus on the superscript, or do
Yes.
you have to like count whether the electron and proton is equal or not?
No, you don't have to count electron. So this is totally different concept, right? Atomic number and finding out number of proton, number of electron, and number of neutron. It is simply based on the math, right? Which you can just find out, look at the periodic table and find that out. This is more complex, right? This is ion. And whenever we're talking about ion, if you are talking about like ionic compound, this is how they exist. So as I told you, there are elements in different group which carry a certain charge, like +1 charge or +2 charge. So that is always true, and that's all you need to know. I'm explaining you this diagram just because you were asking me question, and just so you understand this. Nobody is ever going to ask you to draw this diagram and explain you how the electron moves from sodium to chlorine or Cl, from Na to Cl. Make sense?
Mm-hmm.
But yes, Whenever you say Na lose one electron, yes, you say Na is going to become +1. Every time when you say Cl is gaining one electron, Cl is going to become -1. The same way, if Mg is going to lose 2 electron, it's going to become +2. If aluminum is going to lose 3 electron, it's going to become +3. If phosphorus is going to get those 3 electron, it's going to become -3.
One last question.
Sure, go ahead.
Would there be any case where like proton is 10 and then electron is 8 and then the subscript is still like negative? No, right?
All right, so when we talk about superscript, right? The superscript only talks about how many electron did you exchange. I would say like how many electron that particular element exchange with other element. If it losing 2 electron, it's going to become like let's say losing 2, so Mg +2, or we can say Ca +2, right? If there is any other element which is gaining 3, it is going to be -3. In this case, if we are talking about proton, it doesn't apply. You by looking at the superscript number, it doesn't reflect proton at all. To find out the proton, all you need to see is the symbol. Once you find out the symbol, go to the periodic table, see what is the atomic number, and that is the number of proton. So if you are asking me if there is a 10 proton, then find out which one is a 10 element, which is neon, right? Neon is the 10th element in the periodic table. So yeah, neon is a noble gas, so it's not going to lose 2 electron to become 8. So it's never the case. If I'm going to answer that kind of similar question in here, right, which I already did, but let me just explain you one more time. Oxygen -2. So if I'm going to ask you what is number of proton, simply go and check your periodic table, find out what is the atomic number. We know atomic number is 8, and we know atomic number is always equal to number of proton. So number of proton is going to be 8 as well. Now let's find out number of neutron, right? So what we know the formula, mass number is equal to number of proton plus number of neutron. What is the mass number for oxygen? Is it like 16 point something? Yeah,
15.999.
yeah, so I would say 16, right? 15.999. Eventually we're going to round it off anyway, so I'm just going to say 16 for a moment, right? So it is 16. We already know the number of proton, and we have to find out number of neutron. So if we do the math, right, so we want to get rid of the 8, so -8 from this side and this side. Eventually you know number of neutron is equal to 8. So this is true even if we are talking about oxygen itself, or we are talking about O-2, which is iron. The only difference is in terms of number of electron. If we are talking about oxygen itself, then the number of electron is going to be the same as the atomic number, or we can say same as number of protons. So it's going to be 8. But if we are talking about -2, which is an iron, in this case, what do we know? Atomic number, right? What was the atomic number? Atomic number was 8. And in here, what actually happened? It gained 2 more electron. If it's going to gain 2 more, it means we're going to add +2. So now it has how many electron? 10 electron. Did I answer all your questions?
Yeah.
Everybody is clear?
Yes.
Yeah.
Okay, excellent. Sorry. All right, so I'm going to erase this, and let's talk about isotopes. Right, isotopes. So what is an isotopes? So remember, isotope is a similar element which has same atomic number but different mass number. All right, so it is an element that has same atomic number but different mass number, right? Now if you, I think we did it so many times now, so you know that atomic number is equal to number of proton and mass number is equal to number of proton plus neutron. So what does it mean? It, when you have same atomic number, it means you have same number of proton, you can say that, right? But when we say there is a different mass number, what does it mean? It means the only difference is going to be different number of neutron. Does it make sense? Right? So when we say this, we can say that it is an element that has same number of proton, but it has different number of neutron. Why? Because the only difference is a mass number. In the mass number, it's a part of the formula also says number of protons, so that must be constant, right? So the only difference that can create is the different number of neutrons. Is that clear to you?
Yes, Professor.
Yes.
Yes.
Yeah. So in simple word, if I have to explain you how does it work, so let's say if we need carbon, right? For carbon, how do we find the carbon? So let's just say just to keep it simple, we just say, like, we have to dig some sort of land, and we find out after digging, we do some kind of process to extract carbon, for example, right? Let's just assume if we find out 100% of the carbon, right, from let's say digging some sort of land, out of 100%, 99 of them having a mass number as 12, for example. All right, and 1% has mass number 13. But, right, so okay, let's just talk about that. So this is the mass number. So what does it mean? It means that the compound, or I would say like the element, is still same. It has same number of proton. The only difference is the second one has extra one neutron compared to the first version of it. All right, so it is like having just one extra neutron. Everything other than this is same. We are still calling it as a same carbon. It is still carbon. All right, it still has the same property, it works exactly the same, it just have one extra neutron. All right, do you follow me? So this is different for different element. For carbon, there are two isotopes, 12 and 13. For sulfur, there are three isotopes. For phosphorus, I think there are 2 or 3 isotopes, right? You don't have to know how many isotopes are existing and for each element. All you need to know for this, like any course you are taking right now, all you need to know is what is the formula to find out the actual mass number or atomic mass that you are seeing in the periodic table. All right, so basically all you need to know for this concept is the definition, what is isotope. So you can say isotope is an element which has same number of same atomic number, but it has a different mass number. Or if you want to use different word, you can say it has same number of proton, but it has different number of neutron. That's the first thing. Do you understand that?
Yes, sir.
Yeah, everyone?
Yeah. Yes.
Okay.
Yes, Professor.
Excellent. And the second part for this isotope you need to know is very basic, that every element, like I wouldn't say that all the element has the isotope, but many elements which they have the isotope, the only difference is they have 1 or 2 extra neutron. Everything other than that is similar. The same, they have same number of electrons, same number of proton, and it has same characteristic, work exactly the same, right? But to accommodate this difference, right, when we are trying to find out the average atomic mass, in the other way we can also call it as a mass number. We need to consider both of this. All right, so let me just give you an example the way you may see that question in the exam. All right, so that's all you need to know for this isotope. So let's say in the exam you see a question like this. For carbon there are two isotopes, right? I'm just kind of writing this in very simple language. So carbon, there are two isotopes. The first isotope is having a mass of around, like, let's say 11.99 AMU. I'm just gonna say AMU for now. I know we haven't talked about that. We will discuss this later on, but let's just say this is the unit of the mass. So this is called atomic mass unit, AMU. All right, and if we kind of dig the land, how many percent of this we're gonna find out? So let's say it's going to be like 99.01%. all right, the we can find out the similar element, right? The same carbon element which has a mass number. I wouldn't say the mass number, I would say the mass would be around, I'd say 12.99 AMU, and the percentage is going to be what? 0. I shouldn't say 0. Let me just keep it right. So the difference is going to be 2. Not 2. It's going to be 1.99. 1.99. So for carbon, there is one isotope which has a mass of 11.99 AMU, and the percentage abundance, it means when you kind of find out, let's say 100 particle of them, you find out 98.01% is in this form. All right, and there is another isotope which has a mass of 12.99 AMU, and out of 100 particle, when you of carbon, you found out it has 1.99 of them, right? So out of 100, there are basically 1.99% is isotope 2. Does it make sense? Do you understand the question? There is no question about it, but do you understand the information, I would say?
Yeah, I do.
Right? So this information in actual number will be given to you. This is the number I made up right now. All right, just to make sure that you understand the concept. So what you have to do to solve this problem, so if you have the handout, you will see the formula, right? The formula says what you have to do, we have to find out, and the question can say what is the atomic mass, right? Find out the average, I would say there. Question asks you to find out average atomic mass for carbon. All right, instead of carbon they can give you any other element, but remember, for each isotope you will have two information. You will have the mass of that isotope always, and you will have the percentage abundance, or basically the percentage of that particular isotope. If there are two isotopes, you have this information for both of these isotopes. If there are three isotopes, or even if there are four of them, you will have this information, the mass and the percentage abundance for all three or all four isotope. Do you understand this?
One question.
Yeah.
Is the isotope 1 is different carbon than isotope 2, or is it
No,
same?
it is the same. It is the same. So let me just give you like brief idea that how they come up with the isotopes concept, right? So what we can say, if there is a different number of proton, different number of electron, different number of neutron, we generally characterize that as a different element, right? That's how we have like hydrogen, helium, neon, like lithium, neon, argon, krypton, xenon, right? All of it. Why? Because it has different number of proton, electron, and neutron. In this case, when they in the earlier time, when they find out element which has same number of proton, right, same number of electron, the only difference is number of neutron, and it acts same, looks same. That's why they come up with the definite kind of explanation that this is the isotope. It means it is the similar element, it's just a little modification or little twist in it. Make sense? If an element does contain different number of proton, then it would be different element, right? If it contains different number of electron, it would be different element. In this case, it just contains same number of proton, same number of electron, same characteristics, same look, same appearance, same functionality. The only difference is number of neutron, and that's why they categorize these as isotopes.
I see. My question was just like isotope 1 and 2 are like isotope 1 is another carbon and isotope is another carbon. That was my question, whether there are 2 carbon or it's just you're doing like one carbon and then like different AMU.
Okay, so when you say C, right, the symbol assigned to the element, but even isotope 1 is a carbon, even isotope 2 is a carbon. What I'm trying to say here is when you, let's say, okay, so let's say this, right? I'm just going to simplify this. So let's say if there's a bucket, right? And if I'm saying this bucket is full with a ball, right? So ball is like general term, but let me just tell you, if you want to describe that, there are 2 type of ball, red ball and blue ball, right? So is this the ball? Yes, it is the ball. It has different color. Yes, it has different color, but it is still ball. Do you get it?
Yeah.
The same way, this is still carbon. This is still carbon. The only difference is different number of neutron. So when we're going to kind of, let's say we dig this carbon, right? What we need to do, we need to find out what is the average mass of this isotope, or I would say like what is the average mass of everything that we found out in form of carbon. So this is the carbon, yes. This is the carbon, yes.
Yeah,
You
got it. Yeah,
better?
that's all I wanted to know.
Okay. All right. So yes, this is still carbon, and because they exist in more than one isotope form, that's the one of the reason why your mass number you see in the periodic table always have some sort of decimal point in it. Otherwise, when we call, right, when we say number of proton is a whole number, number of neutron is a whole number, right? That's what I said earlier, right? When we did the math, I said you round it off to the closest whole number. If number of proton is a whole number, number of neutron is a whole number, how come the mass number is always with the decimal point? Do you realize that, right? Why do you have a decimal place in the mass number when we say the proton is something we can count and it is always whole number, neutron is something we can count and it is always whole number? Then why the mass number has a decimal point? Because the same element can exist in more than one isotopic form in which they have different number of neutron. And what we have to do when we calculate the average atomic mass that you see in the periodic table, we have to consider all this information, the information that I just write that down here. What does it mean? So for carbon, to find out the average atomic mass of the carbon, what do we have to do? We have to find out for the isotope 1, we have to multiply this number, right? What is the mass of isotope 1?
11.99.
Multiply by its percentage, right? How many percentage? So percentage, I would say abundance. It means the availability. Abundance. Right? Now you are going to add that with your second isotope. You're going to do the same math for your second isotope. Isotope 2. Again, you're going to find out what is the mass of that isotope 2 and what is the percentage abundance of that isotope 2. If there are 3 isotopes, you're going to add one more step, the similar step for isotope 3. If there are 3 or 4, you're going to do the same. Let's say in this case, what we're going to do, we have 2. So we're just going to plug in the numbers. What is the mass of the first isotope? Remember, this number will always be given to you, right? What is the percentage abundance? In this case that I gave you is 98.1, right? Again, remember, this number will be always given to you. Again, for second isotope, the mass was 12.99 and the percentage abundance was 1.99. All right. just for the sake of understanding, let's say if carbon has 3 different isotopes, actually it does not, but let's just assume that if it had 3, right, we can say there could be one more. Let's say it could be like 13.99 and it could be 0.01%. So just keep on doing the same step that you are doing. Once it is done, you do the math, you multiply this number, find out the answer, right? So for example, all right, can you do the math and let me know the answer just for the first two?
It's 11.75.
Can you repeat the 11.15?
75.
75. And for the second step?
0.26.
0.26. All right, again, all right, this was just simple math, right? You just multiply this two, put it together, multiply this two, put it together. Now when you add this up, right, because I just gave you like, you know, like assuming, I assume this number, I did not actually use the correct number, I just assumed this number. Even if I assume that, it looks like I'm pretty close to this, right? 6 plus 1, so 0, 1, 2, and 1. All right, so what is the average atomic mass of carbon? The number you get, that is average atomic mass of the carbon. Again, I just assume this number, it's not going to be exactly right, but you see what I'm saying?
Sorry, I can't see your screen. Actually,
My bad.
I think you're writing it too down.
Can you at least see the 11.75 or something?
Yeah.
Okay, so then I just, okay, let me just write it down. So it should be, just add them up, right? It is 12.01, right? When you add this up, 6, 1 should be 1, 1, so 0, yeah, 12.01. And what is that number means? This is called average atomic mass, or we can say atomic mass, or we can call this also as a mass number. And this is the reason that because element exists in a different isotope, sometimes it's 2, sometimes it's 3, sometimes it's 4. That is the reason that why your mass number in your periodic table always have the decimal point. Otherwise, when we say a mass number, it is proton and neutron, it is like a ball, right? You can simply count it. The proton cannot be like 2.5. You know, like you can say that there is 2.5 orange. Like, of course you can say that, but in general, right? Either it is 3 or 4. You just simply count it. So in that case, proton is 11, neutron is 12. So it should be just simple answer. But it is not. Why? This is the reason. Do you guys understand that?
Yeah, I do.
Everyone?
Yes.
Yes, Professor.
Excellent. So do you guys have any question from this before I erase? Again, guys, if you're putting something on the chat box, I couldn't see. So if you have any question, please just use your microphone and ask me, okay? I might have missed to answer any of your question if you put it in chat box. So is this good, everybody?
Yes, sir.
Yes, Professor.
Okay, excellent. We still has some more time, so I'm just going to use that time to explain you some really basic concept. I was thinking about talking about ionic compound and the molecular compound and how to name them, but I think it's not a kind of, we don't have enough time to talk about that. So let me just kind of talk about what is the difference between ionic compound and the molecular compound. That way I will also be able to answer your question when you say, how does it work for group number 4A? All right, so let's start with the group number 4A. Simple example is carbon, right? And when we say the element comes together and form compounds, right? The reason is because they want to have 8 electron in their outermost shell. To do that, right, to achieve the octet rule, what this element can do, so they have 3 options. The first 2 options you already know: loss of electron, it can gain electron, and the third option that you may not be familiar with as of now is share electron. All right. So for example, let's say when we talk about carbon, right? The carbon has it is in group number 4a, right? The number of atomic number, right? Atomic number is equal to 6. So number of course, electron would be 6. Yeah. Everybody agree?
Yeah.
Yeah.
Yes.
Okay. So this is nucleus. This is your first energy level or shell, which is going to have 2 electrons. This is second one, which is going to have 4. So as we already know, right, losing electron and gaining electron, how does it work? Either this carbon has to gain 4 electron to achieve its octet, or this has to lose 4 electron to achieve its octet, right? You guys understand this, right?
Yes.
Yes, sir.
Yeah. Or, right, because it's the same, right, it doesn't have any benefit doing this or that. It has to put the same effort. So what it's going to do, it's not going to do either of this. It's going to share electron, and when you form a compound by sharing electron, that compound is called molecular compound. All right. So when two elements share electron to form a compound, right, let me just write that. I'm going to explain you that one more time in as a form of table, but I'm just going to say that when the when two elements, right, okay, I wouldn't say two, right, let's just say when elements share electron to form compound, that compound is called molecular compound, or it can also call as covalent compound. There are two names, covalent compounds.
I have a quick question. So is it basically any time where an element, the amount of electrons it would either need to gain or lose an electron to follow the, I guess it would always be 4 then, so follow the octet rule. So then it would always form a covalent compound versus just
Ionic
losing or gaining electrons.
Yeah. So when,
So always.
yeah, finish your question.
Oh no, I just want to make sure I understood, like that's like a rule of thumb, like anytime that the amount that it would need to gain or lose to be stable is the same number, then it would always share versus losing or gaining.
Yeah. So the sharing, and like I'm gonna explain you more in detail. I just explained you this term because we are going to talk about that here. So let's say if any element is doing lose, like if one of the element is losing the electron, the other element is gaining that electron, the kind of compound we are going to form, that is called ionic compound. Why? Because it forms of ion, right? Like the example we talked about earlier, right? NaCl, it is called an ionic compound. We are going to talk about this difference between ionic compound and the molecular compound in form of table in just a minute, but that's what I am trying to say, right? If there is any element which is interested in losing an electron and the other one is gaining that electron, and when they comes together, it form a compound that is called ionic compound. Why? Because it is forms of iron, right? There is another way to form a to form a compound, which is by sharing electron. So when you ask me about group number 4a, here I'm explaining you that why group number 4a we did not talk about that when we talk about ions, because it does not form an ionic compound. It form a molecular compound. Why? Because it has to put the same number of effort to gain electron or lose electron. So I think it is easier for it to just share this electron. All right, I'm going to show you the example, how to draw the structures and everything later on, not today, but I'm going to show you that. But I'm trying to ask, explain you that why 4a is not considered as a losing electron or gaining electron. Why didn't talk about like why is not +4 always, or why is not always -4? All right, this is the reason why, because they like to share this electron instead of losing or gaining. They like to share this electron.
One question.
Go ahead.
when you say share, like you take it back later, or sorry, like I'm a little lost between like lose.
so
and share.
I think you guys are asking like a two advanced question that we haven't talked about. So again, I'm gonna kind of go off the track, but it's okay. Let me just explain this, right? So in this example, right, let's say this is carbon and it has 4 electron, right? It has 4 outermost electron. So these are the electrons which are involved in forming the compound. The same way for NaCl, the Na, right? It has 2, 8, and 1. The 1 electron was involved in forming the compound. For Cl, it was 7 electron, right? So it is this electron. What does it mean? It means all the outermost electron are the one which are involved in forming the compound, right? When this one is lost, let me change the color so you know, right? When this is going to go here, this Na is going to become Na plus, Cl is going to become Cl minus, and these are going to comes together as a form of NaCl, right? This is what's going to happen. The same way for carbon, this is the valence electron. So these are the ones which are involved in kind of sharing the electron with something else. Let me just give you an example. There is a compound which is called, what is the simplest compound? Okay, let's talk about H2O. I think that would be easier for you to understand at the moment. All right, so in this case, I'm gonna read down example. I'm gonna change this. So oxygen is going to have 2 and 6. Right? Do you agree? Oxygen atomic number is 8. If you want to arrange the electron, 2
Yeah.
in the inner shell, 6 would be outer shell. All right. Now, how this is going to happen? So this is called Lewis diagram. Again, we haven't talked about that. I'm going off the topic, but I can explain you this, that what is going to happen, the oxygen is going to have 6 electrons. So the way we are going to show the electron, I would say, would be like this. We are just going to draw one dot to show how many electron it has in its valence shell. So in this case, this is the first dot, this is the second electron, third electron, and the fourth electron. All right. Again, this is called Lewis structure. We haven't talked about that, but because you asked me, I'm explaining you this. All right. So this is 4 electron. As we see, there are 6, right? So now we are going to put it in a pair. So 2 on here, right? So this is the way we draw the Lewis symbol, or we can say Lewis structure. We write the symbol of any element, and we just represent whatever number of valence electron we have as a dot. So if there is just 2 electrons, we can just say 2 electron. Generally, I do prefer to use just one dot on each side, and then if there are more, we just can make them in a pair. So that's what I did, right? 1, 2, 3, and 4. Because we have 6, now I'm going to make them in a pair. Anyone, you can make them in a pair, like you can do this, that's fine, right? As long as you put 6 dot around the oxygen. Do you follow me?
Yes, Professor.
Yes.
Yeah. Okay, great. And what do we have? The other part of this molecule is H2. It means it has 2 of the hydrogen atom. All right, again, this is kind of off, but I can explain you this. There are 2 of the hydrogen atom. So if we have to draw the same atomic diagram for hydrogen, we know it is just a nucleus, and it is going to have only 1 electron. So the symbol for the hydrogen is going to look like something like this. H and is electron. H and is electron. Why? Because there are 2 hydrogen, right? In the formula, what do you see? It is H2O. It means there is 2 hydrogen and 1 oxygen. You see this?
Yes, Professor.
So what I just did, I just put them together because now it's a compound, H2O, right? It is joined together. What they did, this hydrogen share is one of this electron with this oxygen. The same thing happened on the other side, that this hydrogen share is one of the electron. The same case, this oxygen has shared one of this oxygen with each of this hydrogen. All right. So now let's look at this in this fashion. How many electron do you see around this oxygen? Now,
8.
Count the dots.
Eight.
How many?
8.
8.
8 electrons.
What does it
Yes.
mean? It means it has its 8 electron, right? Oxygen got its 8 electron. It's again,
On the second shell, right?
sorry?
On the second shell.
Yeah, right now.
Yeah.
Yeah, right. So right now it has its 8 electron around the oxygen, right? So remember, like this shell, the way I am explaining you this, you never have to draw these structures, right? You never have to come up with this, right? Do not confuse that with this Lewis structure. All right, I just draw the circle to kind of highlight that, right? You don't have to draw the structure. This is the circle that I draw, it's just to highlight that what I'm trying to talk about. All right, in here, if we talk about the second, this hydrogen on the left side, right? How many electron this hydrogen has right now?
2.
2,
Two.
right? These are the sharing. This is called sharing, right? The same way, this is called sharing. So the electron that you see in this area, they are shared between the oxygen and 2 hydrogen. Do you follow me? And that's how it is
Yes.
making H2O, in which all these elements are happy. When I say happy, it means they have their whatever number of electrons they need to have. You remember I told you hydrogen and helium, they only need to have 2 valence electron, while everything other than this will need to have 8 valence electron. Because we are talking about hydrogen, they have their 2 electron and they will be happy. It means that's the octet rule for hydrogen and helium. They don't need 8, they just need 2. Same thing for the other hydrogen, they don't need 8, they just need 2 and they have it. Also, if you're looking at the oxygen, oxygen also got its 8. It has 6 only, but because of sharing 1 electron by each of these hydrogen, now it has 8. So all these elements are happy. Do you understand?
Yes.
Yeah,
Yes, Professor.
everyone,
Yes.
any question? Any question, guys?
Teacher, hello.